So A plus B star C, and the output of lexical analysis is ID, ID, operator, operator, and ID. So for this, even we cannot generate the parse tree from the predefined grammar. In such case also it will give a syntax error, or sometimes semantic errors. They are divided into again two types, static and dynamic. So static semantic errors means operator is applied to incompatible operands. For example, you take in C language, increment or decrement operators are going to be applicable for only integral data types like integer or character. But applying the increment or decrement operators to the float data type will give a static semantic error. We'll come to know at the time of compilation. But sometimes there would be some errors which are going to be identified at the time of execution. For example, if you have given array out of bound index like x, so if the value of the x is given by the end user, assume that. So if the value is entered by the end user, then only will come to know that whether it is out of bound error or whether it is inside the bound, whether it is error or not. So such we cannot handle it because they are going to be occurred at the time of execution. And some we may get logical errors. What does it mean by logical error? See, logical error won't stop the flow of the execution, but it will give you the output which we are not expecting, right? So sometimes like we are expecting swapping of two numbers and we have written the code, right? And it is no errors, no compile time errors, no runtime errors, but giving a different output comes under logical error. Or if you are calling a function infinite number of times into infinite looping, and that also comes under logical errors. So for example, if you're calling a recursive function without any termination condition, like calling a main inside the main, and if there is no termination condition for the recursive call, then it will enter into the infinite looping. So this comes under the logical errors. And whenever an error is occurred, as I told you, the error will be first thrown to the error handler. So then error handler, what it will do? What are the functions of error handler? So first, it will report the errors clearly and accurately. So what kind of error series occur, right? And if there is a method to recover that error, and it will try to recover that error so quickly, and of course it will try to detect the subsequent errors, right? And if an error while it is handling the error, and it will try to slow down the processing of correcting the programs. See, it should not slow down the process while it is rectifying the errors. See, it should not, right? I mean, say that taking some time, more time to handle errors, right? So instead of throwing that error to the end user, it's useless, right? For example, assume that missing a semicolon, taking 10 minutes of time by using handling methods is useless. Instead, you could have just send it to the end user. End user could able to do that, right, recovery within minutes. I mean, say that within a minute. So you are supposed to write such error handling techniques which are not going to slow down the processing of correcting the programs. So now while you are recovering the errors or detecting the errors, we use a property called viable prefix property. So this will help you to detect the errors. And of course, it will, what is the main goal of this means? So detection of errors as soon as possible without further consuming unnecessary input. See, when you know that, assume that, for example, you take a string make, and what are the prefixes of it? Epsilon, m, ma, mak, make. So this is the prefix of this word. Same way, whenever you have written old statement, then for every prefix it will check the error. Whenever an error is occurred, it will stop it, so that we can reduce the reading of unnecessary input. Then how it is going to be done? Whenever an error is occurred, right, as the prefix of its input does not match with the prefix of any string in the language. For example, you have written here for, right? So you take for, open parenthesis, semicolon, and close parenthesis. But what is the correct statement of for? You should have two semicolons in the for. So then when you are reading it, what is the prefix of it? FOR, it will check out FOR. So we have a valid string. Open parenthesis, we have a valid string. After for, open parenthesis, valid. After for, semicolon, valid. Even though you have not written anything, that won't produce any error. And after semicolon, if you have one more semicolon, valid, no problem, and one more parenthesis, valid. So these all the strings, all the prefixes of this statement are valid. All the prefixes for, right, you can take like this. See, what are the prefixes of it? First for, then for open parenthesis, for open and semicolon, then for open and semicolon, semicolon, for open and semicolon, semicolon, and all these viable prefixes are valid strings. But here, what are the prefixes of it? For, well and good. For open parenthesis, valid. for open parenthesis and semicolon valid, and whenever you get it, this is not a valid, then it will stop reading the input string, right? Like how it is going to be. Same way here. So do semicolon of that whenever it is detected, do, because the semicolon must be there at the end of while. So these variable prefixes help to detect the errors, and whenever it detects the error, then it stops the process of reading the input string and it will go for the error recovery strategies. So when an error is detected, and it will try to recover it. So the error recovery strategies are categorized into 4: panic level, praise level, error productions, and global corrections. What does it mean by panic mode? So in the panic mode, actually we are not recovering it. So simply we are just ignoring it, right? Whenever, see, in this case, what is the main problem we got here? Missing parenthesis, right? So here we should write the closing parenthesis. So what will be happened here whenever an error is detected? So we have to design the designated token that until which symbol we should ignore it, right? See, whenever you get an error like parenthesis is missing, then every statement in C ends with a semicolon. So it ignores everything until it detects the semicolon. Whenever it detects the semicolon, then automatically it assumes that there is an error and it will try to pass the next input string. So that we are just removing this statement from our compilation. And of course, that will be reported to the end user anyway. Then in this level, instead of ignoring the error, so we are going to recover that by using the local corrections. See here, the parenthesis is missing. So in the praise level, like see guys, might be, let me take an example for English statement. See, we have a paragraph where you are asked to identify the errors. Assume that the paragraph is having 10 statements. And the English professor is verifying, validating your statement. Then assume that there is an error starting from the third statement. So it should not, yes, right? The professor should not report this, that there is an error and he cannot submit that. He has to ignore until the next police stop and he has to start his parsing. That's how the panic mode works. In praise level, what we are doing here, see, by using the local corrections, so as we are missing the parenthesis, I don't know if I change here what will be happen before statement or next function or next function, that I don't know. Just I'm going with the local correction and I'm trying to rectify this error by placing the missing parenthesis. Is it going to affect on the other, like for example you are having a variables and you have used some uninitialized variable here, you are thought of initializing the variable within the local, but by declaring this local variable, whether you are changing the meaning of other statements inside the block or before the block, so that we are not worrying in the local, right? So we are just, what we are doing, trying to recover the local error. And in error production, see, instead of recovering it, we are sending a proper message to the end user so that it would be very easy to handle with that error in this. So just write the parenthesis is missing for a printf statement, that every open parenthesis, some informative message we are sending to the end user. And the last one, global correction. Of course, we cannot find the difference of local and say the praise level and global here. Simply we are here also replacing the parenthesis, inserting the parenthesis. But as I told you now, assume that we have a program here and somewhere we have declared the variable. So int a equivalent to some value we have sent. We have taken some other, like a equivalent to false, we have taken something, right? So changing this, like a is not initialized and changing here int or something or boolean, so definitely it is going to recover the local error. But by declaring this a as a boolean, and what is the effect of this declaration in other part of our program, we are not worrying about it. Without worrying about that, we have just recovered this error in the praise level. But in the global correction, we should take care about all the other parts of the program. Then only we have to perform the recovery method. So in the next video, enter something program here. we will parenthesis, inserting the parenthesis. But as I told you now, assume that we have a program here and somewhere we have declared open parenthesis, some informative message we are sending to the end user. And the last one, and in error production, see, instead of recording it, we are sending a proper message. Hello students, in this video we'll discuss about top-down parsers. So last concept was syntax error handling and recovery. So as part of the parsers we have discussed about that. Now we'll discuss what are the types of parsers and what are the top-down parsers. So parsers, main intention of every parser is to check whether a statement is syntactically correct or not. So here the 8 parsers which are listed out, the intention of every parser is to generate the parse tree. From the grammar, predefined grammar, even though the grammar is represented in different forms, right? So the parsers, based on the construction of parse tree, we are mainly divided into top-down parsers and bottom-up parsers. So top-down parser means, as we have discussed in the last video, we are constructing the parse tree starting from the root node and following to the leaf nodes. So where this top-down parser is simple compared to the bottom-up parser, and it uses the leftmost derivation. While constructing the parse tree from the root node to leaf node, the same productions what we have used in the leftmost derivations will be represented here. And the input is going to be scanned from left to right. In both the parsers, of course, we are going to scan the input from left to side. Right. Then bottom-up parsers means we are going to construct the parse tree from the leaf nodes, starting from the leaf nodes and going to the root node, bottom up, right? Then, so it is also called as shift reduce parser, and what are its types we'll discuss once top-down parser is over. So in top-down parser, we are again categorized into two types, with backtracking and without backtracking. So with backtracking means we are not predicting what is the next symbol to be, next production to be substituted. We are just blindly substituting the production. So that's why we can call it as unpredictive parser. And without backtracking, we can call it as predictive parser. So here we require some intelligence to substitute the production. Once it is substituted, you are not supposed to take back, or backtracking is not allowed. And that is divided into mainly recursive descent parsers and non-recursive descent parser, and is also called as LL1. Parser. So the first L is nothing but reading the input string from left to right, and the second L is nothing but leftmost derivation, as I mentioned here, right? Leftmost derivation, and one is nothing but look ahead symbols. And out of these three top-down parsers, this is the most widely used, and this is the only parser where we are going to construct the table. That's why we can also call it as table-driven top-down parser. Out of three parsers, we are going to construct the table for here. Then these bottom-up parsers are complex compared to the top-down parsers, and they are going to use the reverse rightmost derivation, not simply reverse rightmost derivation. It is reverse rightmost derivation, and of course we are going to scan the input from left only. That's why The first parser here, the first letter here and here is same because we are going to read from left to side. Then this R is nothing but using the reverse rightmost derivation. And these bottom up parsers are also called as shift reduce parser, right? SR means shift reduce parsers, and they are mainly categorized into two types: operator presidency parser and LR parsers. So I mentioned that what is L? Input is scanning from left to right, reverse rightmost derivation. Again, they are categorized into four types: LR0, no look ahead symbol; SLR1, so simple LR with one look ahead symbol; CLR1, canonical LR with one look ahead symbol. So this simple canonical LR1 is also called as LR1 parser simply, no need of C. And LA means look ahead parser. Right? So some information about this top-down parsing. See, the parser is constructed from top to bottom, like left to right and leftmost derivation and recursive descent parser we have discussed. And see, for example, this is a grammar, and if you are given ID plus ID, the string, then in leftmost derivation, first we have to substitute t plus t, and this is the leftmost non-terminal, we have to replace it with the ID. And out of these three, this is the only non-terminal which is leftmost, and we can replace it with the ID. So the sequence of productions what we have used here are going to be utilized while constructing the parser in top-down approach. First E tends to T plus T, that is the first production. Then T tends to ID, second production, and T tends to ID, third production, right? So 1, 2, and 3. So the sequence what we have used in leftmost derivation and top-down approach is same. That's what we have mentioned earlier. So top-down parsers are categorized into backtracking, recursive descent, and predictive parser. See, backtracking means blindly we have to substitute a production. If it is not satisfying our requirement, you have to take a backtrack and substitute another. So it is general parsing technique but not widely used because it is not efficient. And recursive descent parser is less efficient, but both parsers are danger of falling into infinite loop for left recursive grammars. Both left recursive grammars. What it is, that we'll discuss in the next slide. To overcome that left recursive, and of course, backtracking is suitable for left factored, but recursive descent parser is not suitable for left factored also. Right? Not for left factored. What it is, but that we will discuss. These two parsers are not suitable for left factored. Of course, even predictive parsers are not suitable for left recursive also. Right? So how it is going to be, that we'll discuss in the next slide. And predictive parsers are most widely used as there is no backtracking, and they are going to represent widely as it is non-recursive and there is no problem with the infinite looping. Even though it is not suitable for left recursive, but these two grammars are falling to infinite looping. But this one also not suitable for left recursion, but no looping. So of course, I'll give an explanation for all. The left factored grammars are not suitable here, but this backtracking can deal with the left factored grammar. Right? You can say like this: left recursion not for all top-down approaches, right? But give an infinite looping for backtracking and recursive descent parser. Not suitable for all, but give the looping for backtracking and recursive descent parser. But when it comes to the left factored grammar, so which is not suitable for, right? Not for recursive descent parser and predictive parser, but no problem with the backtracking, right? And first we'll go with the backtracking. See, for example, if you are asked to generate the input string ABC, for example, so don't consider this diagram, I'll come back to that. So ABC, then you have to take like this. S tends to blindly you substitute the post production. So terminal, no problem, B. Substitute blindly BC. So all are terminals. So this is not our required input string. What is our required input string? ABC, but ABBC is not our required. Then take a backtrack. So then you are going to have S tends to A, B, and C. So for B already we have substituted BC. What is the other alternate? B. Then you can substitute. So this is the backtracking, right? So whenever it fails, right, then what you have to do? You have to take a backtrack and substitute other alternate. So that there is a possibility of substituting all the productions. So there's a problem with that, and it is an iterative approach. To overcome that, so we are moving to the next one, that is recursive descent. But how the left recursive problem here, let me explain. For example, if I'm having E tends to E plus T, this is a left recursive grammar because the left hand non-term is occurred again. Then how it is going to be a problem? As I told you earlier, left recursive is not suitable for any top-down approach, but fall into infinite loop for backtracking. So first E, for this you blindly substitute E plus T. For this E again blindly substitute E plus T, right? For this T again E blindly substitute E plus T. Of course I don't know what are the other productions of E, I don't know what are the other productions of T, but as it is not satisfying, just blindly substitute the first production only until the terminal occurs, but there is no possible write. That's the problem. Infinite looping, top-down process, backtracking. So next one, the main problem with the backtracking is too many backtracks and we have to substitute all. So to remove the backtrackings, we are going for the recursive descent parser. So what we are doing here, simply for all the non-terminals, you have to write the procedures. Here, how many we are having 5. So let me take a simple thing like E tends to E plus T. So if you want to write for this, then simply you can write like this. Procedure, E you write it. If it is a non-terminal, call the procedure. If it is a terminal, check it. If input is equivalent to plus, then you call advance, means you have to read the next input symbol. Then if it is a non-terminal, call it. That's what we have done here. CE, two non-terminals, call the procedures. E dash, terminal, just spaces, right? Check it and call the advance. For the non-terminal, call the procedure. T, FT dash, non-terminal, call the procedure, call the procedure. Star FT dash, terminal, check it and advance, non-terminal, non-terminal. So very simple thing. If it is terminal, call the procedure. Then if it is a non-terminal, call it. That's then if it is a non-terminal, call it. That's what we have done here. CE, two non-terminals, call the procedures. E dash, terminal, just a space is right. Check it and call the advance. For the non-terminal, call the procedure. T, FT dash, non-terminal, call the procedure, call the procedure. Star FT dash, terminal, check it and advance, non-terminal, non-terminal. So very simple thing. If it is terminal, we are having two productions, right? Check it and advance. If it is terminal, check, non-terminal, call, terminal, check it. So if it is not E, not ID, then you can write errors. Right. So very simple logic, guys. And but what is the problem with this again? So there is a danger of fall into infinite looper. left recursive grammar. See, E and E. So first we are calling E, then again we are calling E. E. Again that will enter into infinite looping. Right. So both backtracking and recursive descent parsers are danger of fall into infinite looping for the left recursive grammars. See guys, you can go for it. Here, if it is ID, we have to check it. If the input symbol is ID, we have to write it. Else, again we have to check open parenthesis. Right? ID, then advance. If it is not ID, check for terminal. Then again advance. Right? So in this case, if it is not ID, not open parenthesis, then we are saying that error because we have reached the last non-terminal and the terminal what you are expecting is not open parenthesis, not ID. Then we can say that it is an error. We cannot generate the parse tree. So there we can say that the parse tree is not possible and we can say that that is an error. So what is the problem with the both backtracking and recursive descent parser? There is a danger of falling into infinite loop for left recursive grammars. To overcome this, we are moving to the next parser, that is predictive parser LL1, and of course we use the first and follow technique to construct. I'll go back into simple from top to bottom, use 10 step for production, categorized into backtracking, recursive, descent, and predictive parser. See, backtracking means blindly we have to substitute a production. If it is not satisfying our requirement, you have to take a backtrack and substitute another. So it is general parsing technique, but not widely used because it is efficient, not efficient. And recursive descent parser is less efficient, and but both parsers are danger of falling into infinite loop for left recursive grammars. Both left recursive grammars. What it is, that we'll discuss in the next slide. To overcome that left recursive, not suitable here, but this backtracking can deal with the left factored grammar. Right? You can say like this: left recursion not for all top-down approaches, right? But give an infinite looping for backtracking and recursive descent parser. Not suitable for all, but give the looping for backtracking and recursive descent parser. But when it comes to the left factored grammar, so which is not suitable for, right, not for recursive descent parser and predictive parser, but no problem with the backtracking, right? When it comes to the left factored grammar, so which is not suitable for, right, not for recursive descent parser and predictive parser, but no problem with the backtracking, right? And first we'll go with the backtracking. See, for example, if you are asked to generate the input string ABC, for example, if you are asked to generate the input string ABC, for example, so don't consider this diagram, I'll come back to that. So ABC, then you have to take like this, S tends to, blindly you substitute the post production. So what plans? Hello students. So in this video we'll discuss about predictive parsers, especially the LL1 parsing technique. And the first technique to construct the predictive parsers, we need first and follow. So in this video we'll discuss first only. So the next video we'll discuss follow. So first of all, predictive parser. In the last video we have discussed about backtracking and also recursive descent parser. So top-down parser is mainly divided into three. So this LL1 is the third parser, where L is nothing but scanning the input from left. The second L is nothing but using the leftmost derivation, and one is nothing but the look ahead symbol. Look ahead symbol means while you are reading the input buffer, how many symbols we can read at a time. So one means you read only one symbol, two means you can read two symbols at a time, three means you can read like that. So zero means without worrying about the look ahead symbol, we are just substituting the production. That's the meaning of it. So the intention of every parser is to check whether a statement is syntactically correct or not. So from the predefined grammar. So once you got the tokens from the lexical analysis, now I just want to check whether this a plus b is the input. So where the dollar is denoting the end of the string, it denotes end of the string or starting of the string. Sometimes if you keep here, then how can you generate this input is syntactically correct or not means. So a plus b could able to generate the parse tree for this a plus b from the table where our context free grammar is represented as a table. So you can see this. So our grammar, like expression grammar, is represented as a table. So once the table is constructed, how we have to construct the table, that we'll discuss in the next slide, next video. So then if the grammar is represented as a table and you are given this input string, so if you could able to pass this input string from the grammar, then we can say that the statement is syntactically correct. So to check whether the statement is syntactically correct or not from the given grammar where it is represented as table, with the help of stack, we use a predictive parsing program or algorithm, right? So I'm assuming that the grammar is already represented as table. So how we have constructed it, that we'll discuss in the next video for a grammar. But assume that for a grammar is represented as LL1 parsing table, right? It's already represented. Then the x is top of the stack. Here you can say that this x, whatever it is, that is denoted with the x, top of the stack. And the a is the locate symbol here. So whatever the symbol we are taking, this is a locate symbol, and this is m of x comma a, where x is denoting the row and a is denoting the column here. So this is nothing but x and a, right? So what is the first step? If x equivalent to a equivalent dollar, successful completion. If x equivalent to a but not equivalent dollar, pop up the stack and increment the output. So if it is not 1 and 2, in the third step, if x and a, for example, e and id, so x and a equivalent to a and id, then we have to replace this x in the stack with uvw such that u is occurred as the top of the stack. Means what? Assume a situation like this. So dollar $x and the input symbol is a. So in this case, if x m of x comma a is some production like x tends to uvw, then pop x and push uvw such that u should be occurred as top of the stack. Means we have to push reverse, push w, push v, push u, then continue the process, right? So let me just go with the string here. See, our input string is id plus id star id dollar, and I'm going to take it from this table. Okay, so then first the stack initially contains dollar and top of this starting symbol, as I mentioned. right, initially. So now x is e id. Then we have to take the production from m of x comma id. Means what? M of e comma id. E comma id. What is the production in e comma id? E tends to te dash. So if it is e tends to te dash, right? Te dash. So we have to replace e with the te dash. Then you got like this te dash dollar. Now what is x again t? What is a id only? We have not changed it. Then TID, what is the production? So TID, again T tends to FT dash. Here see, T tends to FT dash. Then what you have to do, replace the T with FT dash such that F should be occurred as top of the stack. Now X is F, A is ID, what is the production? F tends to ID, again F tends to ID. So then you can write F, replace F with the ID. Now see, X is ID, A is ID. If both are same, what we have discussed, if both are same, x equivalent a and dollar not equivalent dollar, pop up the stack and increment the input symbol. Means we have to pop up this id and we have to increment the a to plus. So now what will happen? X is t dash and a is plus. T dash a, what we got? So t dash a, right? A means what it is plus, sorry, a means plus. T dash plus, what it is? Epsilon. So you have to replace the t dash with the epsilon. Then I got e dash comma dollar. Okay. So then again x is e dash and locate symbol is plus. Then what is the production we are going to have here? See, right? E dash tends to plus t dash. Then what will be happened here? So we have to replace the e dash, t dash. We are going to that's t dash. We have to replace the e dash with the plus t dash. Then both are same, then pop up plus and increment the a, so like that. Then t id, so you have to take the production ft dash, then f tends to id, like just repeat the process whatever we have done, right? So simply if both are same, then you have to pop out. If not same, then take the production and substitute. So if you do like that, then finally you are going to get dollar and dollar. So if x equivalent a equivalent dollar, we can say that successful completion. Just iterate the process what we have done, then definitely you'll get the successful completion. So instead of explaining all the stack symbols. So but in textbook we have another method that we'll discuss again, because we have to repeat this step once we are done with the construction. So then we get a doubt like, see how we got this table for the grammar, right? So that we have to do. So to construct this table for the grammar, we have to follow this algorithm. For each production A tends to A, find first of alpha, and for each terminal in first of alpha make entry A tends to. Of course you are not getting it. Just let me tell you that to construct this table, okay, we need two techniques. One is first of alpha and another one is follow of A, right? So if I repeat these steps again also you won't understand now, but guys, once we are done with the first and follow, so again I'll come back to this construction of the table. At the time I'll again explain this algorithm, right? So I just wanted to mention you that to construct the table we need to follow this algorithm, but to execute this algorithm we need to know how to find the first and how to find the follow. So in this video first we'll discuss about the first, then next video follow, and after that we'll discuss the construction of table. So at the time I'll give the same algorithm once again, right? Let me go with this first of alpha. So first of alpha will give you the set of terminals, guys. The first set never ever contains a non-terminal, so it should have either terminals or epsilon, but it never contains epsilon, right? Then the algorithm of first is if x is a terminal, means what? First of x. If x is a terminal, then first of terminal is terminal only. If x is a non-terminal and x is deriving epsilon, then first of x equivalent to epsilon, you can take it. right? So let me just write down examples. For example, first of A is A only because A is a terminal. For example, T tends to epsilon. Then you write first of T. As T is a non-terminal having epsilon, you can take it. Then go for the third one. This is important. If X is not a non-terminal and if X is not a terminal and X is a non-terminal but not epsilon, means if X is deriving some productions like Y1, Y2, Y3, then you can write first of X equivalent to first of Y1. You have to consider only Y1 if Y1 does not derive the epsilon. Right? What if Y1 derives epsilon? Then first take the first of Y1, then remove the epsilon and find out the first of Y2 and Y3. Same. First of Y2, Y3 means first of Y2 only. When if it does not derive the epsilon. If it derives epsilon, what we have to do again? We have to take the Y3. Let me explain with a simple example, guys. See here. So first of E, nothing but first of T. So first you have to go for the first of T. First of T is nothing but first of F. So then what you are supposed to do? First you have to find first of F. First of F, guys, listen here, we are having two productions. What is the first symbol terminal? Take it. What is the first symbol terminal? Take it. That's it. And first of T dash, you go in a bottom up approach, better. First of T dash, what is the first symbol terminal? What is the first symbol epsilon? If it is terminal, take it, epsilon, take it. Well and good, right? Then go for T. First of T is what? First of F. We have already found the first of F, right? What is it? Open plus and ID. That's it. First of E dash, plus and epsilon. First of E is nothing but first of T. What is first of T? We have already found. Open price ID, like that. Same way you can go for it. So you can go for first of bottom up approach, right? First of C, terminal, take it, epsilon, take it. In same way, first of B, if first symbol is terminal, take it, epsilon, take it. Now you'll get the difference here, guys, listen. So first of A means first of D, terminal, you take it. First of B, we already find what it is, G, and if it is epsilon, then you have to go to the next symbol. Don't take epsilon directly. If there is a symbol after that, go to that. So what is the first of C, H comma epsilon? Epsilon means again you have to go to the next symbol. As we don't have any symbol, then you have to take it. Guys, epsilon is a key to go to next symbol. So whenever you get epsilon, go to next symbol. If there is no, then you take it. If you didn't understand, just go for the next one. See, first of B, we have to take each and every first symbol here. So first of B, what is first of B? G comma epsilon. Take G, and epsilon means go to next symbol A. Now you didn't get the A epsilon here now. See, because epsilon we got for B, that's why I've gone to A only. Epsilon is a key to go to next symbol. Same way, first of C, H comma epsilon. Take H. Epsilon means go to the next symbol. B, take B. As B is not derived epsilon, don't go to the next one. Same next A. First of A, D, G, H epsilon. Take D. Already G is there, H is there. Epsilon is there, then go to the next symbol. C. First of C, H comma epsilon. Take H. Epsilon means go to the next symbol. First of B, G comma epsilon. So already H is also there, don't need to take again. G is also there, don't need to take. And epsilon go to the next symbol here again. See, as there is no symbol here, then I'm taking the epsilon. I didn't take for this because B are not deriving. But here all are non-terminals and all are deriving epsilon. That's why I've taken this. So here epsilon is the key to go to the next symbol. Remember that. Hello students, in this video we'll discuss about follow. So in the Hello students, in this video we'll discuss about follow. So in the last video we have discussed about predictive parsers and the techniques to construct the predictive parsing table, that is first and follow. So in the last video we have discussed about first. So in this video we are going to discuss how to construct the follow. A. So guys, we are going to find the first for the alpha, means the first can be applicable to alpha, means it can be n plus t whole star, means you can apply the first to a terminal, you can apply the first to a non-terminal, you can apply the first to a combination of terminals and non-terminals, and sometimes even you can apply the first to epsilon. So that's the reason we have in the first algorithm also we have discussed about that. First of terminal is terminal, epsilon, like, and we have taken the combination of terminals and non-terminals in our examples. But when it comes to the follow is applicable to only the non-terminals. You are not going to find the, or it is not required to find the follow of a terminal in construction of predictive parser. So generally we won't find the follow for a terminal. So we are going to find the follow for a single non-terminal, right? So first, here we are having three rules mainly. If S is a starting symbol, then you have to take the dollar. So, and assume that we are finding the follow of B here, right? So then whenever you're asked to find the follow of a non-terminal, you have to check where it is on right hand side. So if it is somewhere like this, then the follow of B is nothing but the first of the remaining symbols, right? So we have to find the first of remaining all the symbols. If it is a terminal, take it. If it is epsilon, what you have to do, that we'll discuss. If it is a non-terminal, find the first of it. Because either follow set or first set never ever contains a non-terminals. It contains only terminals. Sometimes epsilon in first and dollar in follow. But by mistake also you are not supposed to take the non-terminal in follow set. So here if you are asked to find the follow of B, if B is followed by something, then find the first of it. That's what we have given here. Then assume that if B is followed by nothing, right? If B is followed by nothing, then the follow of B is nothing but the follow of A. So you have to take the follow of the left hand side in non-terminal, right? So to find the follow, what is required for us? First, if you don't know how to construct the first, then it is useless to start the follow. So let me explain this with a simple example. So we have taken this grammar. So the expression is with the simple, then it is. Is useless to start the follow. So let me explain this with a simple example. So we have taken this grammar, so the expression grammar. Then if you're asked to find the follow of this grammar, so then first you have to find the first of the grammar, right? So anyway, you have the things here, you can cross check at the end. So first of alpha and follow of A. So we are going to find the first and follow of each and every non-terminal. So let me go with this, guys. See, it's very simple. When you are asked to find the first, go from bottom up way. Then F, you want to find the first of F. So how many projections F is having 2, then just consider the first symbol. If it is a terminal, take it and just remove the, just ignore the remaining symbols if it is a terminal. And consider the first symbol, again it is a terminal, then take it. Like you have to consider each and every first symbol in each and every production, right? If you are having 10 production, you have to consider 10 first symbols. Same way, now I want to find the first of T dash. What is the first symbol here? Star. As it is a terminal, take it. And what is the first symbol? Epsilon. So remember this, epsilon is a key to go to the next symbol. As there is no symbol, that's the reason I'm taking epsilon. If there is a symbol, then in place of epsilon, you would have gone to that symbol. Same way, I just want to find the first of T. So we're having only production, then concentrate on first symbol. What is this F? You cannot take the F here. Why? Because as I told you, the non-terminals are not allowed in either first set or follow set. Then at the time, what we are supposed to do? So if first symbol is non-terminal, but we need only terminal, then find the first of F. We have already done it. What is it? Open parenthesis, comma, ID. That's it. See, you are not supposed to go to T dash because the F is having only what? Terminals. So you're not supposed to go to next symbol. When you can go to the next symbol if F is having epsilon. For example, if you're having like this, then you're having, in that case, open parenthesis ID, epsilon will allow you to go to the next symbol. Otherwise, you are not supposed to take the epsilon. You are not supposed to go to behind the first symbol. Same way, let me go with the e dash. So what you are going to have here, first symbol is plus, take it. So don't go to the other symbols. And what is the first symbol here? Epsilon. Then go to the next symbol. As there is no symbol, then you take it, epsilon. Same way, and so the first symbol here, non-terminal t. So first of t, we already found it. Open parenthesis, comma, id. So this is how you have to find the first of a grammar. So once you got the first of a grammar, then you can easily find the follow. Not exactly easy, but you can find it, right? So let me just remove all this. Right. Okay. Then when you're asked to find the follow, then going top down approach, reverse. Then I want to find the follow of e. See guys, whenever you're asked to find the follow of a non-terminal, first check whether it is a starting symbol. If it's a starting symbol, take the dollar. And that's not the end of it. And check whether e is occurred anywhere on RHS. Right? Yes, we have here. So e is followed by what? The first of remaining symbols in the production. So it is nothing but first of close parenthesis. So first of a close parenthesis is nothing but close parenthesis only. That's it. And nowhere we have the e. If somewhere we have right hand side, again you have to find it. So on RHS somewhere if you have e, then the follow of e is nothing but first of remaining symbols. That's it. Same way, let me go with the next e dash. Follow of e dash. So e dash is not a starting symbol. So for this instance, don't take the dollar, but later it may come. Then how many times e dash is occurred? Two times, year and year. So e dash is followed by nothing. If it is followed by nothing, then take the follow of left hand side. So follow of e dash is follow of e dash recursive. And same way here, follow of e dash is follow of e. So what is the follow of e? Dollar, comma, close parenthesis. So like that you have to iterate it until there are no symbols to be added. Right? I've done in two ways. See, follow of e dash is nothing but follow of e. Right? As e dash is followed by nothing. Then same way go for follow of t. Let's listen here. So t is not, but later it may come. Then how many times e dash is occurred? Two times, year and year. So e dash is followed by nothing. If it is followed by nothing, then take the follow of left hand side. So follow of e dash is follow of e dash recursive. And same way here, follow of e dash is follow of e. So what is the follow of e? Dollar, comma, close parenthesis. So like that you have to iterate it until there are no symbols to be added. Right? I've done in two ways. See, follow of e dash is nothing but follow of e. Right? As e dash is followed by nothing. Then same way go for follow of t. Let's listen here. So t is not a starting symbol. So don't take the dollar for this case. Later it may come or may not, but we don't know. Earlier we got in e dash, right? So t is occurred here and occurred here. In two places you have to find. So follow of t is nothing but first of e dash, not epsilon, only first of e dash, because this is different production. So what's the first of e dash? We already found it. Plus, comma, epsilon. As epsilon is there, then you have to go to the next symbol. Do you have any symbol here? No. Then take the follow of e dash. So what is the follow of e dash? Dollar, comma, close parenthesis. Of course, you didn't understand this. Let me repeat it. Okay. If you got it, well and good. That's not a big problem. Okay. Now see guys, listen once again. Follow of t. So t is followed by what? E dash. So you should not take the non-terminals. Then take the first of e dash. What is the first of e dash? Plus, comma, epsilon. Take the plus. Epsilon by mistake you are not supposed to take in the follow. In first somehow it is possible, but in follow you never have the epsilon. Whenever you get the epsilon in place of a non-terminal, go to the next symbol. Do you have any symbol in this production? No, because epsilon is different. Then if there is no symbol, in first set we have taken the epsilon, but in follow if there is no symbol, then go to the left hand side non-terminal and find the follow of it. So you write it. That's it. So same way you have to find the follow in the other occurrence of e dash here. You have to find here also. So then you get the same. So follow of t is nothing but first of e dash, what it is, plus, comma, epsilon. Take plus, epsilon means go to the next symbol. As there is no symbol, then find the follow of e, dollar and close, same. Right, then go for follow of t dash. See guys, this is follow of t dash. So now t dash is year and year. As it is not a starting symbol, don't take it. And follow of t dash is follow of t dash recursive. Follow of t dash is follow of t. What is the follow of t? We have already found it. Plus, dollar and close parenthesis. Then go for follow of f. Right. So if you didn't understand the follow of t, just listen one more time for follow of f. So f is occurred year and year. So follow of f is nothing but first of t dash. What is the first of t dash? Star, comma, epsilon. Take the star. As epsilon, go to the next symbol in the production. As we don't have any symbol, then take the follow of t dash. What is the follow of t dash? Plus, dollar and close parenthesis. And task is not over yet. Again, you have to repeat here, but you will get the same. So this is what we got. This is what you can check here. So this is how we have to find the first and follow. So same way, when you're asked to find the first and follow of another grammar, so you can just go with this, right? First find the first, then go for follow, right? First and follow. So as I told you, when you're asked to find the first, go from bottom up approach. That would be easy. So F, right, and epsilon go to the next symbol. As there is no symbol, you take it in the first, but in follow you have to go to the left side. Take G and epsilon, there is no symbol, you take it. And see guys, listen, first of E, first of D is nothing but first of E. What is it? G comma epsilon. Don't take epsilon when you have a symbol, then go to the next symbol. Epsilon means key to go to next symbol. First of F, F comma epsilon. So epsilon means go to the next symbol. As there is no symbol, in first you have to take it, but in follow you have to go to left side. That's the only difference, right? So same way, what's the first of here? C. So B, then take it, don't go left hand side, and epsilon, go to the next symbol. As there is no symbol, then take epsilon. Same way C, and same way A. That's it. Then you're asked to find the follow, right? So to find the follow of each and every non-terminal, you can check here. Let's listen. So go from bottom up approach, sorry, top down approach. Okay. So as there is no sorry, if it is a starting symbol, take the dollar, and as there is no S on RHS, then you can stop. And what is the follow of A? Sorry, B. Follow of B. B is occurred only here. So first of D. First of D means what? G F epsilon. Take G and F. Epsilon means go to the next symbol. What is it? H. You take it. Then same way B is nowhere occurred. Then take follow of C. So C is occurred two times. Follow of C is follow of C. Follow of C is follow of B. What is the follow of B? We already found G, F and H. Same way follow of D. So D is followed by H. As it is a terminal, you can directly take it. In same way, follow of E. E is occurred here. So it is nothing but first of F. What is the first of F? F comma epsilon, but don't take it. Epsilon means go to the next symbol, then no symbol, then take the follow of D. What is it? H, we have just found. Then follow of F is nothing but follow of D. It is nothing but H. So this is how you have to find the dash